Hello, everyone. I sincerely hope you enjoyed that opening keynote. And I'm also very happy to start introducing our first breakout tracks, in which we're going to look at some specialistic sessions in either one of the two tracks. Um, for my track, I have the great opportunity to introduce Hwan, who holds a PhD in applied mathematics from the University of Auckland and has served as a postdoctoral research fellow at the Odin Institute Center of Scientific Machine Learning. His research merges mathematical theory with machine learning, leading to innovative solutions for real-world challenges. Driven by a passion for discovery, he is recognized for his analytical prowess and commitment to advancing the field of applied mathematics. And today, Hwan is going to be talking about edge AI and TinyML application advantages and limitations. Put your hands together because for the first time on Big Data Days, we have Hwan Go presenting. Hwan, the floor is yours.
Okay, thank you. Thanks so much, Jan, for that introduction. I hope everyone can hear me. Is that correct? I'm still perfect.
Absolutely, we can hear you loud and clear.
Okay, so yep, I have a background in academia from PhD to postdoc, mostly applied mathematics and then to machine learning. But after that, I jumped ship and I went to industry. I've been at the startup called Maxwell Technologies for 3 years now. So I've left my academic days quite far behind. We are based in Auckland, New Zealand, so I'm speaking to you from New Zealand at the moment. It's 8 p.m., but it's okay. I'm really happy to have something interesting to do at night. Otherwise, I'd just be playing video games. So yeah, today I'm going to be talking about edge AI, and the title is "The Future is Coming, but you already know what happens." And I really want to emphasize that because technology tends to follow a trend, and the transition from big AI to edge AI is following that trend. So it shouldn't be something too, I guess, unpredictable to you. People can take advantage of that. So what I'm trying to say is it's going to come. It's definitely will come. It's already kind of here, and it's good to ride that wave to see what we can do to make this world a much more efficient place. Is what I'm going for. Okay, so the next slide. Yeah, so intelligence operates passively as well as actively. So what I'm going to do is I'm going to set the scene for the motivation behind edge and AI. And I do want to emphasize that I'm not a trained psychologist. I say passive and active intelligence. They're kind of words that I just made up, but hopefully I haven't made some egregious error against the psychological community and it still sort of makes sense and is consistent in some way. So what do I mean by passive and active intelligence? Well, on the left column is what I would call active intelligence. So problem solving, experimentation, creation, optimization, curiosity. Very much things that make us human and makes us life very interesting and makes us probably the apex predators on the planet. These things here are the main targets of artificial intelligence today. So you guys probably know about ChatGPT, Sora. They're all trying to mimic human behavior. They take in human data, human-related data such as video, text, images, stuff that makes our existence entertaining. And based on that, they help us, for example, solve problems, experiment, create, optimization. It's all really, really fascinating stuff. I'm really happy. Lots of, I guess, money is being put into it, as well as a lot of really intelligent minds. And really, there's some amazing breakthroughs. I personally use ChatGPT every single day, and there's so many of those products that I love and glad are being made. But let's not forget passive intelligence. So what is passive intelligence? It might not be obviously it's interesting at first because it's kind of just a general thing that all living creatures can do, not just humans. So observation, just observing your surrounding environment. Absorption, absorbing the information and details. It could be just simply from your 5 senses, from sound, taste, hearing, etc. Retention, retaining the idea. So, if you know it's cold in the morning, you remember that, you retain that, and it's probably going to help you make decisions later on night, because if it's going to be cold in the morning, it's going to be way colder at night. So you probably want to stay a bit warm. Assimilation of the information, as well as collecting it all together, as well as intuition. I put this with a question mark because it's something I'm not entirely sure about, but I have a suspicion that intuition kind of operates passively. I guess you could think about the right-hand column more of your subconscious mind and the left-hand column more of your conscious mind. But again, I don't want to dare tread into the area of psychology, which I'm not well versed in. I just want to break up these two for the purposes of this talk and in terms of sort of industry focuses. On the left side, like I said, products that are related to this are sort of AlphaGo, AlphaStar. So AlphaGo beat the biggest board game in the Go, the best board game player in the world. So that you probably categorize as problem solving. ChatGPT, Midjourney, Sora, creation, as well as AlphaStar, which is for StarCraft experimentation. That's for active intelligence. For passive intelligence, there's macro products. And I don't mean to say that we don't need people out there. We're one of the few specialized companies that focuses on, I guess, passive intelligence, and I'll expand more on that in my talk. A lot of the other companies, larger companies with product line, but not really dedicated. So one example of passive intelligence, like I said before, is taking in environmental data. So sensors, something as simple as miniature microphones and I guess LiDAR or vision sensors. A lot of the other companies are companies that have a long history in making sensor hardware, and then they've started to put maybe some product lines, they call it smart sensors, a little bit intelligence into their sensors. But it's still emerging and people haven't really dedicated themselves into making these sensors smart. Not saying they're not doing a good job, but I'm just saying that slowly, only a few companies such as Maxwell that are starting to emerge really focus on let's make sensors intelligent, let's make AI specific for environmental data to replicate the passive intelligent processes that us and other creatures and living creatures do. So just to emphasize again, it's still intelligence. It might not be the frontal lobe stuff where all the amazing cognition happens, like winning a chess game, for example. But you've got motor control, taste, the parietal lobe, occipital lobe, the sight, cerebellum, balance, coordination, movement. So in this case, you might think of accelerometers and gyroscopes, language comprehension, memory, in the audio part. So our brains, a lot of focus right now on artificial intelligence. A lot of money and stuff is going in replicating the amazing parts of human brains, our ability to create. And again, I'm all for that. It's really amazing, but let's try not to neglect the other things that I guess maybe not so much make us thrive, but keeps us alive. So this is the motivation for what Edge AI is. Now let me talk about the technology. So to start this is for machine to grow in this direction, it needs to shrink. So this is the crux of my talk. The future is coming, but you already know what happens. And the analogy I'm going to give is with computation. I don't want to delve too much into it, but computation and intelligence are two different things. And computation is one of the world-changing things that we've already experienced. So on the left is an example. In 1956, this is what a hard drive looks like to store 5 megabytes of memory. And in a mere 64 years later, I swear I have a PhD. I'm just a bit tired, but we can make a hard drive that stores 1 terabyte, much larger than 5 megabytes, in something so small. So look, this finger here, you can put this on this finger, and you can barely see this guy's finger on the left-hand column. That's just to really emphasize the difference in size. So what's the sort of fundamental idea here? Well, this is how technology usually works. You start really big and really powerful, and you focus on maybe some niche area. So in the past, computers were for, I guess, scientists or engineers. They weren't seen everywhere. The power of computation was just localized for a certain demographic of people, and development was for that. Once we realized that these things can do incredible things, the natural progression of technology is to spread it everywhere. Make sure everyone can access it so the whole world can benefit from it. Now, you can't go anywhere without seeing computation. Like I was born in 1990, and cars were just, I guess, middle things that moved. And now you've got what GPS, Bluetooth, or all sorts of stuff. There's some refrigerators that have tiny computers on it. You can set anything from your light switches and all that stuff has some sort of mode of computation. And of course, the most obvious thing is everyone has a computer at home. In the past, computers were made specifically for scientists, etc. Now everyone, no, more than that, not just a computer at home. Everyone has a computer in their pocket. Like it's almost as if we're a completely different species. Because of the capabilities of a smartphone, it seems like an appendage, but every single person has a smartphone. The amount of information that we have access to just makes us a completely more powerful creature than merely, I guess, in the 1990s, where no one really had smartphone, or when they did, it just basically was black and white. So my point is that when you find that a technology is very, very powerful and really good, the next progression, the next natural step is to make it small, make it more efficient, and make it everywhere. So we've seen this in computation. So why can't this also be the case for artificial intelligence? And that's what I'm proposing, that we're right on that inflection point, where now people are thinking, okay, ChatGPT and all that sort of stuff. I mean, it kind of already is. It's a massive neural network that has trillions of parameters, but then people can kind of tap into it using an app on their phone, on their computers. But then the neural network itself, they don't have to be that big to be sort of have some sort of place in society. It can be very, very tiny. We just kind of have to make the effort to make sure it's small and make sure it's portable and think about where it can actually improve our lives. So that's the basis of my talk. So TinyML allows us to isolate, partition, and distribute intelligent behavior. So this is what I'm going to talk about in terms of the passive intelligence thing. Imagine you had eyes and ears everywhere. That's the simple tagline. We use our eyes and ears to take in information and then we process it. And there's a lot of things in industry where say for example on a farm you have a farmer and a farmer does a round to check on the farm, but a farmer can't see every single thing all the time. And of course he can put cameras and stuff like that up there, but in the past cameras were intelligent. They could just see but they couldn't comprehend. What if we take, for example, when a farmer goes sees a certain thing, based on that visual one, he makes one simple decision. What if we just design some sort of device that can take that ability both to see and make that one decision and put it everywhere? Then you've got 24/7 monitoring. Not only does it take a lot of effort away from the farmer because farmer wants to go home, they have to rest, they're human beings, but you basically have the same sort of insight, but without having to maintain a human, and you have it all the time. That's the idea of isolating a certain ability, a certain skill set a human has, partitioning it. So humans have lots of skill sets, but then you take out each individual skill set and you be able to distribute it everywhere. In order to do this, well, we got to make things smaller. So cloud AI, as I mentioned with ChatGPT, I mean, I think Meta is buying like how many $1 billion worth of GPUs. It's in large data centers, it's expensive. And one thing we also to consider is there's a lot of ethical issues involved. So there are privacy issues because if you rely on some sort of cloud-based thing that all your data is being sent to, it's one centralized place that you don't really have access to. And it's a fair question to think that what are they doing with your data over there? Mobile phones, smartphones, accessible, locally processed, a bit better, a bit more private, a bit more efficient. But then there's tiny AI. We're talking about very, very small, low power things. This here's a graph to sort of compare it. NVIDIA V100, which is actually kind of old now, to be honest. Yeah, it has 16 gigabytes of memory, 250 watts of power, but costs $9,000. When I talk about tiny ML, I'm talking about very, very tiny. We're talking in the range of kilobytes. Most important thing, $3. You can get intelligent behavior for as cheap as $3. Now, imagine what's 9,000 divided by 3,000. I mean, this is really sort of a brute force analogy, but then imagine having 3,000 small intelligent things, maybe not as sophisticated as what a GPU can compute, but still it might be useful there might be some intelligent behavior that it's not that taxing, but it'd be great if you had 3,000 of those everywhere for some certain reason. This is the EdgeAI or TinyML that I'm talking about. And I also want to talk about the privacy issues as well. For example, computing on the edge. A lot of these cloud AI, you send the sensory data to the cloud AI, and that's where the brain sits. And Tiny AI or the EdgeAI, sometimes the brain sits right next to the sensor. So if you have a small device, let's say listening to audio, the audio comes in to the sensor, it gets processed right on the device, and the outcome, the result, is sent to a data center. But then it's only the result that's sent to the data center, not the audio. So actually your data doesn't leave anywhere. Your data goes into the device, is processed, and then destroyed on the device. But then the interpretation and the insight provided, the information is still available to you without exposing yourself and vulnerabilities and all that data involved. So not only is it cheaper, maybe also more efficient in some cases, because some cases you might need a very simple behavior, you just need it everywhere. It's also potentially safer. So, but TinyML is quite an intense discipline on its own. So this thing is I don't know what you call it, like a 5-way Venn diagram. It's not perfectly accurate, but I think it commutes the point. You need machine learning expertise, of course. You need to make the neural networks. But what you also need is software engineering expertise, hardware expertise, because we're talking about distribution of things. You need to be able to put them on small devices with sensors and distribute them everywhere. And you also need IoT knowledge to get them all to talk together in efficient ways, because maybe perhaps you have some sort of use case of edge AI that operates in a very rural area where Wi-Fi is not so, not so I mean, it's not easy to access, in which case you may need some sort of more lightweight and efficient modality that covers a much larger range, which covers the whole IoT sort of use case. And now if you do all the so overlaps, well, machine overlap with software is like ML ops, data engineering, model training. You overlap that with dashboarding, IoT is dashboarding as well, because you have your neural networks, you have a lot of them. So that's the IoT component, and you want to display them, which is a software component, which leads to dashboarding. Hardware, model compression, because maybe the whole point again is to keep it cheap. If your computation device is $3, but then you only want it to be $3 because you want 3,000 of them, they can't really handle a model that's that large. You need to compress it, and compression is essentially the art of making a model smaller while retaining its accuracy. You may lose a little bit of accuracy, but at least you hopefully don't lose that much, and the trade-off being to put on a really cheap device might be worth it. And then there's also other things. So it's a very multidisciplinary area, and I just want to emphasize that because I work at a startup and we've had to deal with all of these, and it's not very easy to deal with that many people, especially since our startup has only 4 engineers. So we kind of have one for each, which is pretty intense. Anyway, so now I'm going to talk about some of our product lines at Maxo. I'm not trying to use it as advertisement. It just sort of, okay, maybe I am a little bit, but I'm just trying to use an example of edge artificial intelligence. So the first one is the animal health monitoring use case. And this is the one that I mentioned before. So this is a swine farm, and there are a whole bunch of pigs here. Why is this important? Well, actually, during the time that we had COVID, I guess since you guys are in Malaysia, maybe you guys would be more aware of this, but there was another pandemic that affected not humans, but pigs. It was called the African swine flu. And China is one of the biggest pork producers in the world. When African swine flu was so intense that you had to immediately not only kill the pig you found it, but kill the whole herd around it, because it was just instant loss and you didn't want the disease to spread. But they had to cull so many pigs to the point that I think China lost like 1% of its GDP or something like that. It was pretty intense. It speaks to two things: one, how important pork is in our economy, and two, well, how deadly the disease was. And basically, if you could detect the spread earlier, you could isolate the herd that you're sort of killing off. So in this case, if you're maybe 3 days too late, then it's not only the small pen gated by this fence that you have to kill off, you may have to kill off multiple pens. But then if you knew it early and this one pig was coughing, you caught it early, then that'd be great. So this is the idea of what I was saying before. But a farmer has a lot of things to do on a pig farm. It's not just they have to prepare a lot of things, clean a lot of things. The ears can't be available every single time. So the idea here is we've developed a device that can listen and count pig coughs. But why is this intelligence thing? Well, false positives are an issue because a lot of things sound like pig coughs. It's not a thresholding thing, because if you did a simple threshold where at a thing of a certain volume, you hear that sound, you call that a cough, you might accidentally catch a lot of things. Like pigs they're actually quite lively creatures. I've been on a couple of pig farms now. They run around, they jump on things, they're running to the fences, a lot of different sounds, sharp sounds. So as human beings, we differentiate between sounds of things, not by volume, not purely by volume, but just, I guess, interpretation of the signature. So if you've got the sound of a pig cough is a different sort of looking waveform compared to the sound of a pig running into a fence. And to be able to tell the difference between that is intelligence. So you need artificial intelligence for this. So what we did was we put a small neural network inside this device, and it's very, very simple. It's just a microphone, and it's just a neural network, and it's a very, very cheap computer. And it just hangs here all day listening into things. It hears so many sounds, but it's smart, so it knows which one's a pig cough. When it hears a pig cough, it sends that information up to a dashboard. And again, same thing as I said before about privacy. The audio that comes into this device and also the interpretation of the sound of the thing, that all happens on the device. So pig coughs comes in, neural network verifies as a cough, the cough sound is destroyed, and we send up the information to the cloud that a cough has been detected. And this is important because farmers like to walk around. These devices are all over farms. If they walk around and notice microphones everywhere, it might make them nervous, and we don't want to make them nervous, and we don't want to take their data. We want them to be free to say whatever they want and talk about things without the fear of someone else listening in. So this is a very efficient sort of idea where it just listens to pig coughs. When it finds a pig coughs, it sends it up. It's a simple function. It's cheap, but you can put it everywhere on a farm. And this way, farmers can also figure out different trends in their I guess, the efficiency of the farm. Because, for example, pigs are sold based on their weight, and pigs that are sick are pigs that are sick obviously they don't put on as much weight, so they have some sort of ratio as a metric of the efficiency of their farm. It's like if I put 1 kg of food out, does that translate to 1 kg, which would be a perfect translation in weight? So then the cost of food and the cost of I guess the return from the pig is at least 1-to-1. And with this thing here, you get a sort of really widespread granular view of the different farms and the different pigs and the amount of coughs, and you can correlate that to the sickness and the spread and also the efficiency of your farm. So it gives you insights that you've never had before. It gives you counting pig coughs in a granular level and a very localized level, gives farmers an access of information they've never had in their whole history of farming, and they can change their practices based on that. And it's only possible because these things are cheap and you can put them everywhere. So hopefully that communicates one of the benefits of Edge AI. You see this one thing, it's probably not as interesting as ChatGPT because it's not as intelligent, but the point is there's a lot of them everywhere working all the time. And another use case is vape detection. So I don't know how it's like in Malaysia, but in New Zealand and America, we're having a lot of problem with high schoolers vaping. And vape is quite new. So I guess in the past, with my dad's generation, they didn't know that smoking caused lung cancer. So people would just smoke a pack a day. And then when they figured it out, it was kind of too late. Now we have high school students vaping, and vaping on the surface seems safer than cigarettes. I don't know the pathology of how it works, but I think less tar and less sort of things into your lungs. So right now we think it's safer, but when we find out that it's not safe, we think of how many high school students that I guess we're too late for. So high school students are now sneaking vapes and hiding in the bathrooms and they're vaping. And they're being really clever about it because they're also taking their deodorant out. After they vape, they spray deodorant to mask the smell of the vape. That way, when teachers walk around, they smell deodorant. They can't tell whether this high school student has been vaping or not and can't issue a punishment fairly. So what we have is we have worked with a company called Pira that makes these aerosol sensors, and these aerosol sensors detect particulates in the air. So you have particles in the air and different bins of different size particles, and vape is a very different signature to deodorant or to anything else, to smoke, for example. So what you do is you put these devices everywhere. You put a small neural network inside it that can recognize the I guess signature of a vape, which is different from a signature of deodorant. You put them all around schools. Then, as soon as a vape is detected, and they can detect it through the deodorant, they're notified to the teacher, and the teacher has more, I guess, ability and agency to identify who are the culprits, not just to punish them, expel them, but maybe protect them from maybe long-term damage that we're not aware of yet because of vapes. And this also applies beyond high school, because another example is in rental properties and Airbnb. A lot of Airbnb owners, they rent it out and they specify, please don't vape in our premises, but you can't tell whether they're vaping or not. And you definitely don't want to put a camera in your Airbnb because that's just an invasion of privacy. No one will want to stay at your room. So you have these sensors that you put it around, including hotels and rental cars, that as soon as there's a detection of a vape, it's registered, it gets sent up, and maybe you can find them based on that, like add a little, extra charge to their bill because they violated the agreement to use vape. So this is another example. Again, it's a very simple neural network, nowhere near as powerful as ChatGPT, but still fairly sophisticated. Again, a thresholding algorithm wouldn't work. If you did it based on the number of particles, if you vape and you spray deodorant, deodorant is also increasing the particles in the air. So is vape. How do you know the difference? You can't do a threshold. You got to use intelligence, because we can tell the difference between vape and deodorant, not just because we can sense it, but because our brains will interpret in some way that uniqueness of the different signatures. Another use case is fall detection. I guess in many countries, especially Asia, it's an aging population. The birth rates are really, really diminishing. So unfortunately, like me, when we're much older, there's going to be much of us older people around than younger people around. And we obviously, with our older and frailer bodies, if falling could, completely change our quality of life. And if we don't have kids around to sort of monitor us all the time, we need some way to sort of detect and send to, I guess, hospitals so they can respond quickly in case we fall. The tricky part about falling is that it's just a motion, right? But then we do a lot of motions. When sometimes we lie on our bed. So for example, on the left, this guy's falling over, hits the ground. On the right, the guy's maybe just relaxing after a day. What you don't want to do is, when you're lying down a day, then maybe 2 hours later, you hear, hopefully not 2 hours, in fact, 20 minutes later, you hear the ambulance sounds outside because they've supposedly detected the fall, and they've rushed in to try and save you, but you're just trying to get some sleep. So you don't want that. So what's the difference between the left case and the right case? Well, there are obviously small, minute differences in motion, but one big thing is that it's not the act of falling that hurts you, it's the act of landing on something. So I'm guessing that landing on the wet floor is going to make a much louder sound than landing on the right. So again, this is an intelligence thing. We can tell the difference between what's a bad fall and what's a good fall, an intentional fall, because of our intelligent processes. It's not just a thresholding like, oh, if there's a sudden change in angle and acceleration, the person's fallen over. No, you got to combine that with the sound of hitting something and the sound of not hitting something. So we've actually developed a small fall detection that combines audio and motion sensors to detect, to differentiate between what's a fall and what's not. And one of our engineers, Hwan, has created this really cute little demo. So on the right is like a little figurine. It's kind of like Batman, but he has a bunny's head. I don't know what it is. We bought it for like $2 at a local store. Attached is a small board that's developed by Avnet that has a motion sensor and a microphone on it. And on top of that, we put an artificial intelligence, a neural network that can take in both audio and movement. And based on both that information, can we figure out whether this guy has actually hurt himself from fall or he's just relaxing? So you don't have to worry so much on the left about the graphs. I won't go into any detail, but she's going to push it over. And I don't know if you can hear that, but it makes a loud sound when it smacks on the desk. So this will register a fall because the combination of hearing the sound and the motion probably says, oh, there's something dangerous here. But then when she lifts it and drops it, like taps it on the ground, because there was no, I guess, distinct movement signature, the thing won't trigger because it says, okay, I can hear the sound of hitting something on the ground, but I don't see any movement to correlate it against intelligence. You go combine two pieces of information to make a conclusion based on what's going on. And now she's going to get a piece of tissue, which simulates the bed. When it falls over, it goes softer. So although you had the same fall motion, because you can't hear that loud sound, it's a safe movement. So that's another example of it doesn't have to be as smart as ChatGPT, but it can be life-changing, and we need it everywhere. We need it, I guess, discreetly connected to every human being in our eventually aging population to keep us all safe. And again, another good way to detect falls is cameras, but no one wants a camera looking at them 24/7, and no one wants to pay for something that expensive. So anyway, I think that's the end of my talk. I hope it's been insightful, or I hope it made sense, and I hope it sort of indicates that this might be a way, a direction that AI is going to. So I hope again that all the large companies like OpenAI, Meta, DeepMind continue their amazing work, but I hope other companies as well come in and develop these products like we are doing to help on the sort of passive intelligence side, the things that are neglected and more related to more traditional aspects of society. We're talking about industries, farming, the backbones, the very fabric. Social media and all that is fantastic, and it's great for our world. I mean, it's great right now. I get to talk to you guys in Malaysia presenting for how far away, like instantly. It's all great, but let's not forget about the things that sort of keep us safe and keep us alive, not just keep us entertained. So thank you very much for listening, and I'm sorry, Jan, I don't know what to do next. Do I just stop sharing my screen, or is it like a Q&A session?
Yes. There is a Q&A session. Indeed.
Yeah.
Let me start sharing my screen already.
Okay.
And then we will look at some of the questions. There were quite a number of questions that were coming in.
Oh, they were.
So I'm going to moderate them for you for a second. I'll just go in order of the most popular questions first.
Okay.
Let me project it. You should see it on the screen right now. First question is from Katina, and it's just a fun question. How small do you think technology and AI will become? Will we have computers so small that it can't be seen with the human eye? Computers we can use through contact lenses or implants or anything similar?
Oh, interesting. So I'm not a hardware expert. My focus is more on the artificial intelligence and the sort of mathematics side of things. But that would be really cool. Like I think if the motivation is there, because you know what they always say, it's not science doesn't progress about what's possible, it's about progresses what people want. So I always figured that if humans wanted flying cars more than wanted mobile phones, we'd have flying cars and not mobile phones. So in this case, if we can break through and see how effective AI can be at what size, I'm sure the hardware will be motivated to follow. Although when you say contact lenses and vision, it makes me a little bit nervous. So I want to say that our CEO Saba, who's originally meant to be at a talk, she's an AI ethicist, and at Maxo we take that stuff really serious because we're trying to develop monitoring solutions, but our emphasis is to make people feel safe, not just physically, but just in general. Don't feel like your privacy is violated. So yeah, it'll be really cool to see how far technology can go, but then let's also always, just like with AGI, let's hope ChatGPT doesn't go so big they create like the world-ending AI, but let's hope we don't go too small that no one has any privacy or any agency over their lives. But thanks for your question, Katina.
That's a very good question indeed, and I fully agree with your answer that there will be some point or moment when the ethical considerations also here get into play more than just the technology.
Yeah.
Good. We have still a lot of other questions. So I'm just going to go through them one by one.
Sure.
Next one is from Rob, if I'm pronouncing it correctly, and please correct me if I don't. But the question is TinyML open source? And that's actually quite a good question that I was asking myself as well.
Oh, that's a really interesting question. It's difficult. Okay, I'll be honest. Maxo is not open source. We have training algorithms, IP, we protect by patents and all that. It's a tricky question. I mean, I maybe I'll just deflect a little bit to OpenAI. OpenAI is not really open anymore. It's now closed AI, but then they have a good reason. They had trouble attracting. They had a lot of trouble attracting. I guess talent because they couldn't give the compensation packages required because of their open source. But I will say this: our passive intelligence and all that, we're targeting the sort of more fabric of society, traditional industries, and that includes government. And if government is using taxpayer money, and because it's taxpayer money, it should be open source. So I think we're still more in the private sector, but we've started making moves towards governments because governments are interested. And because it's taxpayer money, because we paid for it, everyone should be able to see it. There might be a very, I guess, sustainable way to do open source without losing the talent, but also making sure that, the talented people get paid well to actually contribute back to society. So that's another thing I'm very excited about in terms of machine learning, because it's really hard to have governments over, I guess, social media. People are already trying, but then we're targeting things that things already have governance over. So hopefully this is a way that, again, the main point is for the people.
Yeah, no, I fully understand. And my kind of follow-up question was more, is that the term TinyML, because I think I've seen it somewhere else as well.
Yeah.
Is that developed by your company, or is it basically building upon existing machine learning algorithms that are already in play?
Yeah, so there's many facets. If you remember my crazy Venn diagram, so TinyML has a hardware component of it because there's a lot of companies now developing very efficient chips. They put neural networks on it. We don't put on that side. We more develop algorithms that are really focused on the environment. So we have a lot of proprietary algorithms to develop neural networks for audio, for aerosols and stuff like that. In our employment, we have people who have combination of both machine learning backgrounds and traditional science backgrounds. So aerosol physicists, biologists, and for me, I used to do some medical imaging stuff. That's where we sort of come in with the type of data that we interpret. And also there's compression algorithms that we don't do as much of, but there's another great people. So it's one of those things where, you need a whole lot of different people to make the world spin. So I guess to focus on what we do is we have very good skill set of processing environmental data and to train neural networks. That's what our focus is. But there's a lot of players in this.
Good. Then I'm going to get to another question, which let me project it on the screen, which is from Sosmuts Gachui. And again, please forgive me if I'm pronouncing the attendees' names wrong. And it's kind of a question that builds a little bit upon your previous discussion around the ethical part of things. So the question is, I need to think about, taking animal health monitoring as an opportunity for business. Where do I start? I think the question behind the comment is more around how do you balance these possibilities that AI brings with the ethical responsibilities that organizations have in general, and balancing especially the profit motive versus the privacy perspectives and different elements that come into play, if I'm paraphrasing it correctly.
I see. I think I have an answer. Let me know if this is on the right track. But I will say, although we're trying, our goal is to upgrade, I guess, traditional industries. But because you're clashing between traditional and modern, there's a bit of a, I guess, hurdle you have to get over. Is that sort of what you're referring to?
Yeah, absolutely.
Yeah. So definitely trust is one big thing. Like, for example, farmers, when you say AI, everyone talks about, I mean, you watch Black Mirror, it's all horror stories because that's what sells. And we did feel a little bit of difficulty making them feel comfortable because we're coming in with technology that they don't even, again, this is not an insult, but they're in a different field. They don't really understand at all. And when you're talking about intelligence, how do they feel comfortable adding this sort of stuff to the field? So that's why we did a lot of priority on EdgeAI, really explaining to them at the very least, if it's a brain processing data, at least the data doesn't leave the device that you can hold and physically in your hand. So there's definitely a lot of soft skills involved that you have to. My CEO is much better at this than I am, but in terms of talking to industries that are very orthogonal to what you do and making them feel comfortable and also interested in upgrading this sort of thing. And of course, the profit thing is more of a business model, I guess, because we have a lot of different opportunities, but some of them we can't tackle them more because we're a small startup. There's definitely a more traditional business element of cost profit analysis, which is not really my field. I'm more on the technical side of things. But
Good.
I guess the bigger hurdle is not really the business side and profit, because that's a thing any business go through, but the sort of like navigating and merging between two very far different fields, the very modern with the very traditional, and having the sort of, I guess, common sense and respect, I guess, to be able to do that is very, very important. And a lot of that respect comes from ethics, to show that you're there to help, but you're not there to sort of penetrate and violate, and making them feel comfortable and making sure your intentions are good. So that's a strange thing that I never expected to come out of this company, but something I had to learn to, I guess, improve on.
Absolutely. And then let me be the first to say that I'm glad that you're on the technical side, because that I think is the most interesting perspective for this conference and this part.
Yeah.
Good. You might see on the right hand side that the questions keep pouring in. I'm gonna try to do two or three more.
Sure.
So I'm trying. So for everyone else who's listening, if you have a very question that you agree with and you'd like to see answered, please use the upvote, because I can only do so much in the time that we have. I'm going to go to a question which I also think is interesting, and that is, you talked about the use case of the vapes, and the question is, are these type of vape sensors costly, and do they detect the frequency in which vapes are used?
Okay, it's a fair question, and I would take this opportunity to advertise for our partner Pira. So they're not us, but I guess if they benefit, we benefit profit too. So a bit of that disclosure aside, they specialize in making these air quality monitors, these sensors, very cheap for everyone. They're like a small USB device that everyone can have in their home. Do they detect the frequency in vapes are used? Yeah, I mean, by frequency, every time it detects a vape in instance, it sends it up, and then you have a log of that one instance. I hope that's what you mean by
yeah, I think that's, and just for my reference, obviously I'm not in this whole domain, but are we talking about a few dollars, of tens of dollars, or is it into the hundreds of dollars?
It's still hundreds. I think $250, but usually aerosol sensors and the industrial kind go up to 1,000. So they've really made a breakthrough, and they're trying to make it even smaller to make it accessible for everyone.
Good, interesting,
But
very interesting use case.
Yep. But if you're selling to hotel chains, from my understanding, a few hundred here and there for each of your things, especially if for an Airbnb case where you can also add a fine, is actually, it's kind of worth it. If you think about the benefits you get for the $100 that you're spending, I think it's 250 USD. Yeah.
Yeah. Okay. Good. Then I'm going back to one of the questions that I see that also receives a lot of upvotes, which is again from Sarab. I think it builds on the previous question. Is the URL tinyml.org, or is that something completely different?
That's completely different. We are Maxo, macso.ai. I'm actually interested. What's tinyml.org? I think I do know it.
Okay.
If I notice, interesting. We actually won the EdgeAI product of the year with the vape sensor through these guys. So that's why I know of these guys. So we're affiliated with them, but it's not the same company.
Okay, good. And just for clarity, I think those are always good questions so that people don't get confused.
Yeah.
Then let me go to one that also touches a little bit around public utility of these kinds of solutions. And this question is coming for Kirta Ruben. And he says, we need more products that help to solve day-to-day issues faced by our public. Is there any government initiative running to promote this?
Currently, I hope so, but not officially. So with the smoke and vape detection thing, and now New Zealand government, there has been interest. We've been talking to some politicians. I don't think I can disclose who, but there's a lot of interest in this to sort of like do a formal crackdown on vaping in high schools. So we have some governments interested in that part. In terms of the pig monitor, I think so. Yeah, we have some government connections, but it just hasn't been formalized yet. But there is interest, and I think it's only a matter of time. Actually, with the aerosol air quality one, I can't speak too much about this, but we use it for not just smoke and vape detection, but based on air quality, based on sort of there's a government, I forgot the word, but there's a regulation put in place, that requirement of buildings to uphold some sort of air quality, and this was motivated by COVID. And there's an AI product that we're developing in line with this. So I think eventually, this is my hope, that AI becomes a commonplace in the sort of runnings and initiatives of governments, and that way it'll be available for everyone. So I do agree with you. Definitely need more product to solve day-to-day issues, even though ChatGPT solves much of my day-to-day issues already.
Good. Yeah. Well, if as I mentioned, I've been running this conference for quite some years, and it's been a question that comes back every year is around government involvement and also how they can stay on the train with all these new developments, because it's going so fast, and typically legislation is not going at the same rate, or at least at the same pace. So it's a question that keeps coming back and back. And let me just say that I hope a lot of government officials are listening this week.
And that's also why we emphasize ethics, because we understand that if there's ethical dilemmas, you have to do the regulations first before you uptake it. By making sure we take the responsibility of the ethics, make sure that hopefully we spend less time on the regulation, more time on getting this out to the people in some systematic way. So yeah.
Good. I think we have time for one or two more. So I'm just going to once again take the one with the most votes. And this question says, how do you see the relationship between AI and big data evolving in the next 5 years, and what trends are likely to emerge?
Oh, so I mean, with this conference, there's already a quite strong relationship between AI and big data. But in my personal experience, is one thing we sort of omitted is that sometimes there's a lot of data available and we don't know how to train the models for. And that's when the traditional sciences should come in. So there's this one case where we worked with lambs, and they have this beautiful data set. Everything's well labeled, and they want us to help detect the mortality of lambs. And that's an intelligent exercise, but even humans didn't know how. So what you need is biological models that represent this sort of like mortality based on the data that we can sort of turn into artificial intelligence. Why I'm saying this is I'm glad that a lot of new undergrad students are going into artificial intelligence and computer scientists, because obviously it's really fantastic. But don't forget about the usual biology, chemistry, engineering, all that, because if you want to deal with environmental data and you want to make use of all the data sets that's really curated and collected out there, you need those traditional models. Or else how is artificial intelligence going to learn something that we can't even figure out? So the trends are likely to emerge. It's more like right now the traditional sciences, natural sciences are dying a little bit for computer science. So hopefully they re-emerge, I guess would be my answer.
That's a very interesting line of thought, because one of the previous speakers that I spoke to also said, the next breakthrough is not going to come from a data scientist that invents something new and forward, but it's going to come from a biologist or somebody who is in traditional chemistry that starts to learn around AI and then applies that to a specific use case. So I kind of think that you share that.
I won't lie. After I finished my mathematics degree, I went to machine learning because there was a lot more money, and I was really glad to see that actually a lot of my mathematics, I guess, training and medical imaging can apply to the products that we have. So I kind of sort of regretted me chasing the money so much, and hoping that the traditional sciences still don't get ignored and neglected, just like the traditional industries, which is kind of the point.
That's maybe very, very honest from your side. I'm gonna close with one more question, and this question I think is also kind of at the heart of the conference, so that's why I'm going to kind of pick it up. Question is from Liam, and he's asking, what are the expertise required for developing and optimizing models for this sector? And the reason that I'm picking this question is because this is obviously all about knowledge sharing. So I'm really interested to hearing your perspective on this.
Oh, definitely I recommend referring to that Venn diagram. So the first four horsemen of TinyML would be hardware, IoT, software, and machine learning. But then, as I mentioned, I don't know how to put it on that graph because it'll make it a bit uglier. But science, traditional sciences, need to be involved in there too. So there's a lot of expertise, and I think this is the cool thing about the thing is that we need a lot more collaboration. This encourages people to collaborate. In my opinion, ChatGPT is a little bit behind closed doors. There's a certain niche of skill set that people can develop that, and they do it without anyone. Not saying that they're deliberately neglecting people, but the thing was a much more focused skill set. Whereas this one requires and gets everybody involved, from the farmers to the vets to the audio developers, the ones who make the microphones, to us, making the machine learning models, to the IoT people, to the people who do work with sort of weak Wi-Fi in rural areas. It's very much a many people sort of endeavor.
Good. Yeah. Hwan, that brings us to the end of our time. How was your first experience presenting at Big Data Days?
Yeah, it's fantastic. I hope one day, because my parents are Malaysian, so I hope one day I can actually be there.
It's a global conference, so we're hosting
right.
it from Malaysia, but it's basically it's going from Australia all the way to the US.
Oh, cool. Okay,
so
it's been great. Thank you so much for inviting me.
Absolutely, you've been a great speaker. I really thought you had some very, very interesting use cases. So on behalf of the Big Data Framework Alliance, I really like to thank you for being part of our session today. And we obviously hope to see you again next year.
Yeah, I hope so too. Thank you so much. Have a good evening or morning, afternoon,
Good.
I think.
Wherever you are in the world.
Yeah.
Good. I see a lot of people clapping their hands, so I think most people are really enjoying the words that you said.
That's cool.
Good. For everyone else, the next hour, which is 15 minutes from now, we're going to listen to somebody on the other side of the planet, in Europe to be exact, to Vitaly Kenchku, who's the Chief Executive Officer at Red Flags. And besides that, he's also an Enterprise Big Data Framework Alliance Ambassador. And I know from experience that he has very great talks around a lot of content, really a content guy. Note that on the other track, the workshop is still running in terms of the practical use cases and building prompting techniques. So if you would like to switch, that one is still going on right now. And if not, we will see you back in 14 minutes from now to listen to the talk from Vitaly. Thanks, everyone.